aluminum cannot be welded. I am deliberately making a statement which is likely to trigger some people in the industry saying, what do you mean sir, aluminum cannot be welded? Meaning you cannot weld aluminum easily using a small manual metal arc welder, which you use, otherwise we call it arc welding. But other shielded arc and argon arc welding and all that are possible. Only thing is it is not as easy as mild steel or steel welding, little more advanced thing is there. But on the other side we have this beautiful resistance welding is much better. Resistance welding requires very high capacity and welders and hence not available in small job shops. Argon arc welding, that is the requires high skill and process control. Typically you have an immersed gas arc welding. If you take care of it, it is a very good business. You can have resistance welding or you can have argon arc welding or something, it is a trade name, a variant of gas welding, it is called eutectic welding is available. So possible. But if you have to do something quickly and do it yourself, that is the reason probably why mild steel can still be done. We are getting into a beautiful area called extrusion of sections, cheap and easy. Enclosure systems made up entirely of extruded profiles and interconnecting hardware have been developed and available from suppliers. Just before the Second World War, while everything was sort of done in a way, spin-off from the fabrication process now, just like you have furniture systems. So in fact this nice thing what I am sitting on, this whole thing is assembled with aluminum extrusions. We have extrusions on which the desktop is suspended, and then at the back we can have monitors, and I am sure some of you have seen it in process control or in pictures and so on. So I will see if I can locate the picture of somewhere I had downloaded, yes, you see. Oh, that is lot of extrusions and extrusions and extrusions. Structural, all these are structural. And then even things like corner brackets, you see here, I have a beautiful corner bracket here. That is also made of an aluminum extrusion. Actually it is a simple L angle, this L angle has a gusset like thing, all of them are formed and it comes in a long section. Then a machine either cuts or shears them, after that piercing or drilling is done and we have beautiful pre-made hardware. The bottom section, all this bottom section is full of hardware. The top section is all the materials which are extruded from raw. So we have these enclosure systems made up entirely of extruded profiles, and the moment the initial intellectual property claim is got over, they are now freely available everywhere locally, and then of course our neighbor, depending on where you are, makes these things very easy. I will go to not a very connected thing, but as an anecdote it probably makes sense. We have all heard about the solar panel. So in between, in the solar panel you have that small actually silicon photovoltaic cell, and then that panel is the large thing in which all the interconnections, various safety things, you have a glass, then you have a backing sheet, all these are put together. Now that frame which is put on this is invariably aluminum. No other choice. After a lot of things have been around for since 1970, and finally after 40 years that has been fairly standardized. So, we have these sections in which you just push things into each other and so on. What started as $100 per peak watt eventually came down to $2 to $3 a peak watt. Now, with further optimization, it has broken the dollar per peak watt, and then there things are available even lower than that. Maybe you get 2 peak watts per dollar. I have read on the internet, not yet come, but why I am saying is all that materials used everywhere are invariably lightweight aluminum and made with extrusions, standardized. There is hardware, you just need to put the glass, put all the interconnected photovoltaic cells, and then neatly place a backing sheet, and then put the frame, and then you put the connector assembly, and then everything is done. It is also electronics. Extrusion technology helped us. Next thing is die casting. Aluminum can be easily molded. Non-ferrous casting practice is well developed, and tooling costs are nominal for small runs. Good quality non-porous thin-walled parts need high pressure die casting. This I have samples here on my table, I will get back to it. It's expensive. However, we need to work on it. So, first let me show you the pictures from the catalogs. We have one of those nice. You see, we have I am not very sure if it is aluminum or not, something which is probably made of aluminum. Die casting. So, if my people can show me the samples here, please put on the sample, sir. Can you switch on the samples? You see here, I have collected something from my lab just like that. This is what I was talking to you yesterday. It has that what do you call a pyrotechnic PIR sensor. We have some lenses. This whole box made of plastic. You see the sound? And then when I open it, we have all the electronics loaded inside. Quite nice. And then in detail you cannot see, other lectures I will cover. There is a small groove here, and corresponding to this groove, corresponding to that projection, we have a groove here and there is a provision for a gasket, and then after we close it, it becomes practically waterproof. Seen here? Positive thing is it is a non-metallic plastic enclosure, but then this is what I was telling you, it is probably a little difficult to make such things. Now I will hand you over or take you to, same thing can be done in inexpensive plastic. Okay, you will see a lot of difference between this. That one is a polycarbonate, and then this is probably made out of cheap, cheap is not a good word, inexpensive polystyrene, not full ABS, that may be polycarbonate come ABS. See, there is a marked difference in the finish, quality and all that, but then this costs only 1/4 of the other material. Why I am showing you this is that slowly we are getting into special materials. You see here, this one is a contactor. I am not very sure where it has come from. Looks to me not threatening, but these are all special plastics. We have something called polyphenylene oxide, polyphenylene sulfide, and then some very unpronounceable acetyl copolymers, polyphenylene, some methylene or something like that. So, some of these parts, hard parts, are all made with those things, and then it's just a wonder. It's a wonder as to how an object like this can exist. While that was all done nicely with plastic, now you see this whole thing not yet saved by the bell, I still have a little time to go. This is made out of die cast aluminum. Yeah, it is probably giant some I think 155T. It is hard, it is rugged, and then you remember I was talking to you about a finish. So, this is the brushed finish. After doing all the various operations, they have passed it through some technique by which I am not able to catch the particular this thing. So, we can see a gentle texture on this, but inside is the raw as it comes out of the machine. Main attraction being we can mill all these things conveniently and very stable. Okay, I expect that is a special process, I have no clue how it is milled, but then I expect they probably clamped it here, and then there is something called a milling cutter has passed, made two passes, one with a rough cutter and afterwards something has finished it. And in high speed production, it is even possible to make this automatically in the tool. So, if you go to your automobile section, the whole automobile thing is cast in pieces, no further except a small operation here of the facing of it, remaining comes directly out of the machine. In this case, you can buy these enclosures. Succeeding lectures will, subsequent what you call modules will teach you about how to select a particular enclosure, and then how to populate it with all the electronics, and then how do you make all these openings. Okay. How do you specify an opening, and are there rules for specifying the openings? Now we come to the original thing saying, as the circuit come first and the enclosure afterwards, as the enclosure come first or the circuit come there. Me being on the enclosure design side, I will not take a hard stand saying you better fit your parts inside, but then I won't take somebody else's parts and try to push them into the enclosure, because it is a repetitive, pointless exercise. But right now in the beginning, instead of having the over the wall approach, if you have a, I want to avoid the word, but concurrent, still if the designer can integrate himself with the team, so we can have a reasonably well presented nice equipment which also forms all the NEMA or IP specifications and functionally satisfies everything beyond what a simple box can do. So, let me get back to my presentation. At the other extreme, you see this beautiful we have a beautiful die cast enclosure, and then they have some ribs. Ribs seem to have a multiple function here. One of them is they make it stiff. Another is the moment the surface is a little like this, either by natural convection or by mild airflow, you can make things cooler inside. And then as I pointed to you earlier, if you can mount your things on this inside if you can mount it, you can transfer heat directly across the wall. Oh, very interesting shapes here. Very clever, I will say, beautiful detailing has taken place here. One of them is you have this nice fasteners here, then there is this usual what do you call gasketing system, but then you see some small boss like things here. See, inside small bosses are there, there is something here, there is something here and all that. This has multiple functions. One is it will stabilize the fin, it will aid in the material's movement and all. Probably other side of it probably has a tapping in which you can hold all the hardware inside. I will see if I have a better picture. See that beautiful color, it is not plastic. In fact, it is an aluminum die cast enclosure, because at the bottom you can see still the aluminum color is there. And then very practically they have used this gland nuts and then optimize the whole material and thing. And then you see we have here a beautiful hinge there. So, it is possible you hinge it out, and I mean you release the catch here, remove all the screws, and then you can even remove the cover and continue with your work, which is possible only with aluminum. Now, plastics try to work a little. My favorite. I never liked thermal business, but I am deeply into it. So, I had no choice but to learn, and then I can teach a few things about it. Now, if you see this is a classical heat sink. One side of it is absolutely flat. So, you can attach something onto it. You can put power devices directly on it, or you can attach something, and then you are seeing the fins are very close. Fins are close, and then not only they are close, there are grooves, fins on fins. So, this will generally give us a feeling, or it is a hint that this is probably used where the air flow rate is not that what do you call that high. These are very rarely used in forced cooling. So, because something called fin effectiveness is there. If you are to cool this using a big fan, the tips part of it will get very cold very fast. But then there is not enough material for the heat to flow here. This part will continue to be hot, this part will continue to be cool. So, this can't be used in forced convection. So, this is probably a natural convected part of a natural convected cabinet or something. And then these heat sinks, we have something else here, you have seen this. You can see this type of construction in your pumps. Even a motor which has windings and this has iron core inside and you have copper, outermost part is probably made of an aluminum extrusion and everything is assembled into it, and you have bearings and then end plates, and then probably if it has a pump you have an impeller, or if it is various other things or just a motor. The casing usually outermost is made of aluminum, just like I told you about the boxes. We have a really beautiful example here. It is a whole computer made fully out of extrusions. You can see this, there is a small screw here. So, obviously this piece is one extrusion and the sides are also extrusions, and there is a small gap here. You have seen there is a grooves here. Then there is a slightly different type of orientation of the grooves here, plus there is a provision for us to attach this. So, you have a full enclosure fully made out of aluminum. Only thing here is these connectors do not look like they are professional sealed connectors, but still this can handle a lot of heat without you worrying too much about it. You see this, beautiful. It is really something we enjoy all the time. I think now I will come back to where we have started. This is part of that 19-inch rack. And you remember I was mentioning about some sizes of openings and all this. So, here it is just out of necessity they have made perforation so that air can go inside easily, because generally these are all installed in typically dust controlled environments. You do not put big fans and all that. While it is nice to have a fan, instantly the same fan you will find in your vacuum cleaner. So, vacuum cleaner, other than making noise and making people look busy, it also sucks up dust. Same thing happens if you were to put a very complicated device to just without any fans, if you without any dust collector, if you put it, chances are they will collect more dust than required. However, a simple perforated enclosure like this with things made out of appropriate materials, structural elements which need strength have to be thick aluminum profiles or thin steel profiles. So, you can end up with very beautiful objects like this. You can see here, you can see it a little inside. Do you see something here? This is a shelf, and the shelf itself is used fitted with other hardware directly onto the rack. So, now if you look at an object like this, some parts which are shining and all that, it is possible this is intentionally made very shiny handle, because it should look like a handle. Other things are made a little dark so that it does not look unsightly, and then you have beautiful perforations and lot of optimization has gone into making these sections the correct this. That is why you have the tapered section. So, you keep going like this. Now, these are all other details which I think typically if you are to take a equipment like this, when you see these thin sections and something like this, you can make a guess that it is probably made out of mild steel. And then if you have some handles and these things, and then you have a neat cute front panel, probably it is made out of aluminum. Then you see all those LEDs and those things, either they can be exposed directly or you can have an acrylic or a polycarbonate cover on it. Generally, though you see them like that, probably it has a polycarbonate cover. Then you see here on top, this is probably an aluminum cover with perforations, where I mentioned to you about the 2.5 mm. So, generally they get covered with this. This is probably very generic type of thing. It will show you something of a little bigger thickness. So, this pitch is called U. So, you will come into that later. So, depending on it is 1 1/4 inch plus half an inch. So, we will come to a very peculiar 41.44 or something. So, depending on these pitches, you can assemble things here, different materials. This is probably the smallest one single U rack. And then you see here, we have a nice convection, what do you call, forced convection fan. Yeah, I think this set about covers all this. I will stop with this pictures thing after showing you one of these boxes, which is the same thing which is mounted on the pole there. This hardware is for the mounting on the single pole, and then these are the gland nuts. Then you have various items which are required for holding all the parts inside. Then you have bosses here in which you can mount PCBs. Then I think I have already explained to you about the gland nuts, and then gasket, most important, no? Gasket, you cover it, you seal it, and you are ready. So, we have a lot of pictures here taken from commercial catalogs, because it is not necessary for you to every time go about inventing the wheel again and again and again. But then there are spokes, you can work on the spokes, you can work on the diameter, you can work on the alloys, you can improve it. So, any application suitable enclosure is already available. The one I showed you earlier was the one that has to be mounted on the pole. The only how to tell the problem is if you have to depend on a single supplier, will there be a problem? So, yes, if you are in such large quantities, there are enough people who will supply you, but 1 or 2 quantities, probably it is easy for you to go to the net and then try to buy these things. I just showed you several pictures which are related to high pressure die casting. Per se, aluminum is costlier than mild steel 2 to 3 times. Hence, local manufacturers do not adopt this for cost sensitive commercial applications. Real. As such, you won't have it, and if you really want something to be made quickly and fast, you can't beat. Obvious thing, it looks okay at one level, saying aluminum is only 1/3 the weight of steel. So, flat panels are easier to handle, and items like oscilloscope and other field and portable professional equipment are all made almost entirely of aluminum. Now, they are being slowly being replaced with several polymer applications with good results. But still, next time you have a chance, go around, look at a cell phone tower. Wherever you walk by, you can see the cell phone towers, or even in your building in one corner, you are likely to find these enclosures where the DTH or fiber optic links or various repeaters, various bandwidth managers, all of them get terminated from outside to the inside of the building. If you look there, you still will find lot of die cast enclosures because of the toughness, ruggedness, and then you need to keep them there. So, even if accidentally a spanner hits on it, except getting a nice clanky sound, I like my sound, except this nice sound, they will not get damaged easily. So, you can continue to use these things. Basic aluminum sheets are available easily. Alloys containing silicon, magnesium and copper are however not very common. Heat treatable alloys, sheets of varying hardness are only available on order. So, you cannot go to the shop and expect them to stock materials which you need, but they are specialist suppliers all the time. Several extrusions used in the building industry are commonly available. Building industry extrusion. So, typically door and partition frames, window channels and false ceiling hardware are still available. If you are a designer and then you are quickly looking for making something out of it, it is very much possible for you to use all these things. Oh, we have very interesting thing. Does aluminum look good or not? When you talk about oranges and apples, yes, steel is good, so is aluminum is also good. It is much better to saying no wood is good, but wood is scarce, and yes, wood is used in all these things, notwithstanding all the environmental consideration. Still, aluminum has a smooth appearance from light grey to bright. Some items like profiles are supplied anodized or passivated. During storage, scratches are acquired and may have to be buffed out for external appearance. So, when you buy these sections, in case something is visible on the outside, it is possible that you need to buff it. Basic aluminum has no texture but has visible grains. This can be enhanced to give a characteristic brushed look. So, very easy, they take an aluminum sheet and keep applying emery or a steel mesh on this, and beautiful scratches are formed. Most colors from highly polished white to dull black and iridescent colors can be easily obtained by anodizing and dyeing the color. And in fact, all those gift wrapping and something used in the apparel which shines are all probably polyester foil on which aluminum has been deposited continuously using spray or vacuum or I do not know. Only thing is, normal spray painting cannot be used, you cannot take a can and do it. So, improve adhesion, usually etch priming has to be employed. Powder coating with curable dry epoxy powder is available. So, aluminum has certain advantages. Whenever you want to make enclosures, aluminum is still a matter of choice. This is the last but one slide. Conductivity. High electrical conductivity is beneficial for forming the return path of electrical ground inside an equipment. Contact resistance after bichromate passivation is low, can be controlled by surface modification. So, conductivity of this, you cannot get the magnetic part of it, but electrical is fully under our control. The reason why even electrical conductors slowly are being replaced with aluminum in place of copper. The last slide, which I would like to take a break, is, oh I am sorry, last but one, thermal conductivity. It is very high thermal conductivity, is a preferred heat sink and heat bridge material. All heat sinks at the equipment level use aluminum. I have already shown you an extrusion, and because of the extrusion process, it is possible for us to optimize the design of an extrusion. So, you can have effective fin, where at the base it is thick and towards the end it is what they call, it is tapered, and then it does not restrict the flow of air. So, all if you go to and see a catalog of extrusions used in the heat sinks, you will see this well. Optical. Whenever we talk about optical, it looks like we are only talking about something which passes light through, but then something which reflects light is also very, very important. All reflectors and visible light use aluminum either as formed sheets or as vacuum deposited films. This is the last slide. I can give you a reference only to, I can give a reference for you to the bread toaster that we have at home. You have seen the bread toaster. Typically a bread toaster, you can see the iridescent, if you look down the toaster, you can see the filaments, they are red, meaning high temperature, and then your bread nicely gets toasted inside, but then you do not find the heat on the sides, which is, at least the cheaper ones are made of plastic. It is solely achieved by putting an aluminum reflector inside. Both sides you find a thin aluminum foil reflector which will reflect back all the radiant energy onto the toast which you are trying to toast, and then after you leave a small gap, maybe between 5 to 8 mm gap, it is sufficient for it to insulate all the outside plastic body with this. Only in the top where the heat comes out, maybe a little bit of work has to be done on that. So, we have a beautiful this thing. The basic toaster inside is all made out of usually steel. Some parts of it are made with mild steel, parts of it are coated with nickel, and then the heater itself is carried on a, it is called a mica sheet. Right now, as yet they have not found a simple alternative to mica sheets. Some variants of plastic are possible, but they do not use it. And then you have a shelf which pops the toast out. All that stuff, including that spring, everything is steel. Sometimes the box outside may be made out of aluminum. Whether it is made out of aluminum or plastic, you have heat reflectors which are just inside, behind the side heaters. So, that little bit of aluminum foil, usually it is very thin, probably it is 0.5 mm and embossed and nicely mounted, and it is, in fact, it is very flexible. Once you put it, you do not find any of the heat anymore, and because of the way the openings and all are made, by natural convection hot air goes up, and then we have a good choice of materials, and you have very good toast to go with your milk or coffee or something. So, I will stop my lecture here. Next round I will see if I can take you on a small tour of small equipments and all we have in our lab, which you can have a look, and then I will point out to you saying, you see, this particular device is a something which is made out of this material. I can probably show you a few extrusions and all that, and then subsequent lectures you can probably start making an actual equipment. So, thank you.